Got a problem here. It's f of x equals 2x cubed plus 3x, and we're going to find the derivative, which we'll call f prime of x, and we're going to find the tangent line at x equals -1. Now it's not a hard problem, but it is a time-consuming problem. So to run through our limit definition of a derivative, we're going to need f of x, which is given to us, 2x cubed plus 3x. And we're going to need f of x plus h. So f of x plus h will be 2 times x plus h cubed. That's going to be the pain. Okay, that's the one that is going to hurt us. It says it's erasing, but it's not. Okay, and then that's going to be plus 3 times x plus h, which is not difficult at all. So let's try and finish this thing up. Let's see here. We'll have 2 times x plus h cubed. Well, that's going to be x plus h times x plus h squared. So we'll use that. We'll follow that out. X squared plus 2xh plus h squared. And then it'll be plus 3x plus 3h, considering that we can distribute the last one pretty easily. Alright, now we've got to multiply the binomial and the trinomial, which is kind of aggravating, but let's do it anyway. So we're going to have 2 times x cubed plus 2x squared h plus xh squared plus hx squared plus 2xh squared. We're going to join on another line down here, plus h cubed. I should have 6 terms here. 1, 2, 3, 4, 5, 6. Okay, and we'll close that parentheses. Then it'll be plus 3x plus 3h. So let's clean this up and push that 2 in. So we'll have, this still working on our f of x plus h. We'll have 2x cubed. We're going to have, let's see here if we got anything that's alike here. We've got some x squared h's in here. We've got 3 of them, and then they're going to be multiplied by 2, so that means we'll have 6 of them. So plus 6x squared h. And then let's see what else we got in here. We've got xh squared, so we've got 3 of those inside, so multiply it by 2. We'll have 6 of those, 6xh squared. And then we've only got the single h cubed, but multiplied by 2, so it'll be plus 2h cubed, and then plus 3x plus 3h. Now that was a lot of work just to get set up. So, but this will be much easier than some of the other ones we've done, just because everything cancels nicely. So remember our derivative definition, f prime equals the limit as h approaches 0 of f of x plus h minus f of x all over h. So we went to all this trouble to find that f of x plus h. So let's go ahead and see if we can stick it in here. So limit as h approaches 0 of a really nasty fraction that'll have a h on the bottom. The top will be 2x cubed plus 6x squared h plus 6xh squared plus 2h cubed plus 3x plus 3h, and that all comes from the f of x plus h. And then we're going to subtract off f of x, which is 2x cubed plus 3x, and we squeeze that in there. So let's see what's going to reduce here. There is a 2x cubed from the x plus h and a minus 2x cubed if we distribute from the f of x. So we can knock those out. And then we've got a 3x from the first part and going to be a minus 3x from the second part. Those will cancel. So then we don't have a whole lot left. Well, it looks like we have a lot left, but let's see. Just kind of take a look at the terms we have, and they all have an h in them. So we're going to have the limit as h approaches 0 of something over h. I'm going to pull an h out of the top. So it'll be h times 6x squared plus 6xh plus 2h squared minus 3. So I can cancel an h out of the top and bottom as a common factor. I'm going to save myself a little bit of time, and I'm going to go ahead and let h be 0 in these cases, which will wipe out some other terms. And in the end, this derivative that we've been calculating, f prime of x, will be 6x squared minus 3. That's the derivative that I can use to calculate the slope anywhere I want to along this curve, anywhere that's defined. Well, a little odd setup here, but let's find our tangent line. So our tangent line will need a y. So let's see, our y will come from f of the point we're looking at was -1. So when I plug that into my 2x cubed plus 3x, that'll be -2 minus 3, so it looks like it'll be -5. So that tells me I will have an xy point of -1, -5. And then my slope will come from plugging this into the derivative. My -1 into the derivative will be 6 minus 3 equals 3, because I'm plugging into the 6x squared minus 3. So my m is 3. So I have a point of -1, -5, and a slope of 3. So let's plug that in. We'll have y minus -5, so that'll be y plus 5 equals 3 times x minus -1, so it'll be x plus 1. So that will give me y plus 5 equals 3x plus 3. Get y by itself, we'll have y equals 3x minus 2. And that is my tangent line. So I'm going to pause while I go create that graph to compare it to. Alright, let's stop the presses and go back and look at something. I made my graph and I found out I obviously have a problem, and if you were doing this very well on your own, you probably did not have the same problem. So let's use this little green here to kind of highlight what I change. But up here, when I pulled an h out of the line with the plus 3h up here, I changed that to negative for some reason. So let's make it positive, which makes our derivative formula 6x squared plus 3. So coming over here, that's telling me that if I make these changes, trying to let my pen catch up, that my slope should be 9. Come on, Mr. Eraser. So we're going to let the slope be 9. Make these changes. Highlight all the changes. And that means I'm going to have to change a few more things over here. So this is what happens when you're working. All types of crazy stuff ends up falling apart, but that's okay. Let's see, we're going to change the slope. Lots of things will change. That's okay. So what happens here? When we make that 9, the slope 9, we'll have 9x plus 9. So we got y plus 5 equals 9x plus 9. So I'll move the 5 over so it looks like it should be 9x plus 4. So let's see here. I'm going to go over to the graph I made. So I need to get rid of this tangent line that I've got. But right here in red, I've got the graph of 2x cubed plus 3x. It looks like an x cubed graph, a little bit changed. And then I'm going to put on the point -1, -5 down here. Let's slide it up a little bit. And then I believe we just calculated our tangent line to be y equals 9x, and was that plus 4 maybe? Yes. Okay, let's go back and double check though. 9x plus 4. Okay, much better. So a little bit hard to tell there when we're so zoomed in, but when I zoom out, it looks, well, it's going to cross over up there, but it looks good. It looks tangent at that point. Maybe if I go in, it will look even better, but it's so close to looking like the x cubed line right there that it's really hard to tell because they're overlapping. Okay, so keep in mind I made an error there. You're going to make errors. If there's ways to check yourself, it'll come out best if you take that option. So hopefully we make as few errors as possible, but we always try and find them. All right, thank you.